Hello everybody. Hope you guys are doing well. So continuing today, we would be starting with what design patterns. Like we have covered some patterns, but then now we'll try to understand more about them. Now, what are design patterns? So design patterns are basically a solution to basically these are solutions to common a solution. These are not code. So basically, so these are not code. Basically, these are solutions. Now, what solution is basically, if you have a specific scenario and then if you want our code or the way we write our code to follow solid patterns or solid design principles, um, we will make use of these things. So solid, so our aim goal is to make our program or the code we write to achieve or to satisfy the solid principles. Now these are blueprint, but templates are these are not code. These are templates that can be applied to different situations in our code. Basically, what we are going to do is we are going to use these templates and to design our code in the same manner so that we can achieve or we can satisfy the solid principle. Now these are basically architectural patterns and they will be used again and again. So broadly our broadly our solutions are classified into four types, right? So if you see this classification, it's very logical as well. So first is basically, if you see, solid, we are trying to create an object, right? So first thing that we should do is basically with creating objects. So then we have some patterns. So first, in any object oriented language, the first job is basically to the process of creation of object, right? So this is our basically first a first goal, right? So then this is nothing but called as a solid pattern, right? So this is basically the first classification. This is basically how we would be creating objects. Now the second design pattern is basically related to how objects are composed or related, right? Like how they. So then the other problem that arises after creating is how to relate these objects, right? So how to relate, how to relate the objects. So that classification is nothing but called as um, structural, right? So this is like structural design patterns. The last is basically how objects will communicate with each other or how they will behave with respect to each other. So last is basically how objects are going to communicate with each other. So I'll say how objects are going to communicate with uh, each other, right? So this side of design pattern is what we call as behavioral, right? So basically we are related to it's related to the behavior of the objects, right? So basically this is nothing but called as behavioral behavioral design patterns. So what we would be doing is, instead of using the traditional flow, we would be starting first with behavioral design patterns, and then as soon as we get times, we will start with structural um, or and with creating objects. Ideally, we should start from here because the first thing that we learn is basically how to create an object, right? So if you are learning, you should always learn the creating objects first, and then the structural, and then the behavior. Okay. Now let's see the behavioral design patterns. So behavioral. So like, what are the types of, or what are the classification in that do we have? So behave. So basically, the first thing that is we are going to study is like classification of behavioral. Right. So as we said, behavioral patterns are going to define behave. So these patterns are basically going to decide how the objects are going to interact with each other, right? Uh, Objects are going to interact with each other, right? And basically how different objects will collaborate with each other. Basically we are going to see how the delegation of responsibilities is going to happen. Like each will be given a certain role, right? So delegation uh, of responsibilities. So responsibilities. Then you have avoid using if else, right? So avoid 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 if else change, and then making our code more maintainable. So basically make our code easier to test and maintain. Easier to test and maintain. Okay. So now in behavioral patterns, there are different types of design patterns, right? So basically in behavioral is like a major heading. So in that we have different categorization, right? So the first we have is basically strategy pattern. We'll see why that name is strategy and what problem is it solving. The next pattern that we have is something called as an observer pattern. We see why it is an observer and what problem or what is the ideal case to use the observer pattern. Then we have the command pattern. Then we have command pattern. Then we have something called as, and then we have chain of responsibility pattern. Then we have chain of responsibility. So basically we have 5 to 6 patterns. So we have chain of responsibility, and then we have a mediator pattern. So we have something called as mediator pattern, right? And then one more we have is basically the state pattern. So we'll see what that does. uh, State pattern. Okay, so the first basically the pattern that we are going to use is strategy pattern, right? So let's see the use case, and let's see what does the strategy pattern say. So let's go to strategy pattern, and let's see. Okay, let's uh, so what if we avoid the strategy pattern? So let's see an example where we are going to uh, let's see A real world example of strategy pattern. Okay, let's go back to head first so that we can. Okay. Okay, so the first basically we are going to do is something called as behavioral, and then the first thing that we are um, the first thing that we are going to do is basically um, so we'll see what the problem is that we are solving and see how strategy will help. Like, what is that strategy that we are saying, and why has that name? What from where has that name come from? Okay. Okay. So, for example, use. So let's think of an example. For example, let's see we are going to design a class basically that is uh, basically we are going to design Google Map. So you have this Google Maps. So basically you have Google Maps, right? Now what all features do you have in Google Maps? Basically, first you'll have the ability to search an address, right? So you will do search and address. The way the Google Maps work is first is basically you put your address. Now then it says mode of transport, right? The mode of transport can be that you can walk around, or you can have different modes of transport, right? So that then that mode of transport can be first can be walking. Then the other mode of transport that you can have is basically something called as running. Then you can do running, right? So you can do running, or else you can take an Uber, right, or a car, something like that. Then you have something called as car or your own vehicle. So now, based on what you are going to select, it is going to calculate the possible route, right? So the possible minimum route, the possible route that it will take, so that you take minimum time, right? So you take minimum time again based on your running. We are going to calculate the possible route that you can take when you are in such a way that you are going to run for the minimum amount of time, right? And similarly is car, right? Basically you are going to take the minimum possible route time, and this is basically going to indicate the your minimum distance, right? So basically you are going to decide a route that is going to take the minimum possible time, and based on your mode of transport, it will select the site. So it can be public transport as well, right? So it does give you the option of having a slower. So then you have mode of so like for example you have public transport, right? So you are taking public transport. So public transport. So again, using this as well, you'll be able to calculate the possible route. Okay, now the problem. So First is basically we need in some mechanism to check what mode of transport are we using, right? So first is we need to check the mode of transport. The easiest way to do this is basically use an if slider, right? For example, I'm doing if and then I'm saying my mode of transport. So my mode of transport is walking, running, car, or public transport. So we will do this, right? But what is this? By doing this, what are we? So we are violating is basically we are saying that our so if suppose if I'm adding a new mode of transport, for example, new construction takes place, and then I'm going to add after a few years, for example, then I add a new mode of transport. So that new mode of transport is, for example, like metro or light rail tram, right? LRT. So light rail. Now, if I am using an FL slider to represent all the mode of transport, the problem with that is the moment I try to add a new transport, I need to change the original code, right? I need to change. So I need to change the mode of transport code, right? I need to add in changes to this thing. So by doing this, what we are doing is we are trying to modify the main logic, which is not what the open close principle says, right? The open close principle says that it should not be able to modify the code, but sorry, it should be closed for modification and it should be open for extension. That means we should be able to use an extension to extend it. So now what the strategy pattern says is um, so now instead of having to like um, uh, instead of having so how our code will be like is, the first is we are going to have the main class for Google Map, right? So then we have the main class for say that is Google Maps, and then in that we have different conditions, right? So if my mode is something, then I'm going to call some method, right? So then call some method relevant to calculate distance, right? To calculate the shortest uh, to calculate the shortest path, and also to give me, right? Then if I have some, so first example, for example, my if my mode is initially it's say walking, so this is walking, right? Then the other one is say my mode is running. Okay, consider walking and running the same, right? So suppose if I want to go cycling, then again I will have to call the same method, call some method that is relevant to calculate the shortest path. Then if I do an elif, and then if I say my mode is equal to say walking or cycling, and then I have something called as driving or taking an Uber, right? Then I'm going to call some method relevant to calculate the shortest path, right? Okay, so I'm going to call now what if we add a new mode of transport? So when if we add a new mode of transport, the problem that we are going to face is we will have to modify this thing, right, and add a new mode. So by doing that, what we are basically doing is we are not following the open close, right? So by doing that, what are we doing is now we are trying to modify the original code itself. Like we are modifying. So what if we have else if my mode is say new. So then new mode. So if I have a new mode of transport, then again I'll have to um call some method which is relevant to um, calculate the shortest path, right? So again and again I'm adding new modifications, right? So basically this is not what we want. Why we don't? Because there are certain like advantages, right? We don't want to play with the logic over here, because we can use certain other methods. For example, you can build in interfaces or certain. We don't want to hamper the original logic should be as the way it is. You should not be able to. If you're adding a new feature, you shouldn't be able. The feature should be such that the code should be written in such a way that we should not be able to handle this part. Like we should not be able to modify this part. Instead, we should be able to do an extension and then add the new behavior. By that, what we are doing is we are making sure that the original code is remaining as it is. If there is a bug, the bug should come in our new code, not the original one. Basically, it is making only, so we only need, if suppose this part has already been tested, then we shouldn't be wasting time to test back again the same thing. We should be testing the new part, the new mode that has been added. Now, what? So that is one problem, right? So we are having, so it doesn't fail signal responsibility, right? Because it does not, because there are no multiple methods here, so it does not fail single responsibility. Yeah, because um like suppose we are not adding multiple functions in here, right? It's basically the same thing. This all cases will be written inside a function, right? So you have a function present here that is a that is like define mode of transport. So it's all present inside this. So as long as we are having one function, we are not causing any issue with our, the single SRP is not getting violated here because everything is written in a single function, so we are not violating that thing. That's okay. Now, so if you see solid, so I have S and then I have O, and so basically, what are we not violating when we are writing the code this way? So S is not getting violated. The moment we come to yes, we are violating this. So the way to solve that, reduce that violation is, now how do we fix this thing? No, this is the most trickiest part. What should we use? So basically, we will have to use, either we'll have to extend it, either we'll have to use an extension, because OOP only has two things, right? Either you do an extending or you use, basically this is what, in other words, basically what we are saying is this is inheritance, right? Either you use inheritance, or the other way to achieve that extension behavior is you do something called as implements, or basically you do an implement, or basically um, you use an implement, or so or in other words it is also called as an interface, right? Now we'll have to work on these, we'll have to check now which is going to suit for us, or both of them will be only be able to extend and will be able to modify, right? So both of them supports that. Now um, will support modification only, sorry, will support extension, will support extension and close modification, right? So which, let's start with inheritance. Like what if we try to use inheritance? Okay, let's see what if we use inheritance to solve the extension problem. Then where are we going to lack? So what we will be doing is uh, so what we could do here is let's have a base class. Say, so let's take that root strategy out. So let's have a base class. Say this is root strategy. So one way to get rid of the defaults is you have what some spelling mistake strategy. Yeah, when you have this base class called as root strategy, and then inside you have define a method, right? Say this is going to be my function, which is going to say build route. So build route, and then this is going to take in three parameters. First is basically my start point, then is my mode, which mode I'm using, and third is my endpoint. Right now, what I can do is so now. Oh no, let the mode also be not be present here. Even that is. So what we are going to do is now. So basically, this is my base class. So now I'm going to make this class to implement. Sorry, to extend. Right. So now what if my different modes are going to extend? So first I'm going to extend this thing to say driving. Then I'm going to say let's have a mode that is working. Then again let's have another mode, say so basically all the modes that are available are going to be going to use this, right? So then let's have one is using air travel, right? So you can have using air travel as well. And then again what one you can have is basically uh, one is basically walking, driving, skiing or something. Or let's say cycling is. Now what if air travel is not possible? That means what I'm trying to say is, what if I'm in Mumbai and I want to travel in Mumbai? So this is Mumbai. What if let's say this is I'm in Toronto. So let's say I went in Toronto. This is my start destination. I have to give this. So my start is Toronto, and then my ending is also Toronto. So my end point is also Toronto. So my end is also. Does this make sense to have it over here? So what are we feeling is we are trying to, so by doing this we have solved the solid principle, right? Like we haven't solved the solid, we have. So if you see in our acronym, the principle we are trying to resolve to is basically we had already solved. So S was never a problem here, so let's ignore S is as a problem here. Let's increase the size. Yeah, so S was never a problem for us, so let's get rid of the S. We had a problem with so S was never a so S was never a problem, right? Now we had a problem with O, but we got this by doing we say like either you can do inherit INHS for either you can use interface. So if you are using the first approach, we are using inheritance. But then the moment we come to inheritance, this core substitution fails. How is the failing is, for example, if I'm trying to now and I'm searching, so it shouldn't show me a route that says you take a flight, right? No, this is not something logical, right? Because how can you travel within? So the airport is only one, right? In Toronto, there is only one airport. How can you use an airport to get to an airport if there is only one airport in a city? So that is when we are going to fail the list cost we are going to fail Liskov, right? Liskov substitution. So what does Liskov substitution is? If says that we are um, uh, yeah, it is basically failing because of this base class inheritance, right? because now we are making every class to inherit from this. So then um uh so we have run into that base class problem, right? So then we say, oh yeah, we have violated that pattern. So then now what we should do is, this is nothing but we're, hence we say inheriting this is not a good option. So then we go to interfaces. So let's say, but then the moment we go to interface, so remember we need to have two things in mind. The first thing is basically we need to have this list cost substitution, and then we need to segregate the interfaces are separate, right? Everything should not be present in one. So now what strategy pattern is trying to, so what we do is basically we will take out everything outside. So let's see. Okay, so now we are going to use uh, um, now let's see like how is my interface going to solve that thing. Okay, now what we are going to do is, so instead of using inheritance, now we are going to use interfaces, right? So let's define an interface. So I have an interface present here, and whatever class is going to be present, all those classes are going to just so whatever class will implement it should be able to get that thing, right? So what if we use interface to solve the inheritance problem? Hmm. So what we are going to do is we are going to have an interface being present, and then so in this interface we are going to define a contract. So let's that's what typically happens, right? You define a contract here. We define a contract. So let's have a contract placed over here. Okay. Uh, this is our interface, and we have defined the contract, right? Now whatever class or whatever, so let's say the thing which is going to implement this interface will have to provide the concrete implementation for this, right? So whatever is going to implement is going to provide the concrete implementation, right? So now first is there is only one interface present, so we have also saw, like, we have overcome the so now let's go back and check what are we what all principles have we overcome here. So let's see again. The first principle that we have was in our was single responsibility, right? But this was never an issue here, so let's get, so we were having an issue with those, so for that we chose now interface, right? Because inheritance we face in an issue with Lisco, so now we have gotten rid of both O and L as well. Now we have in I. Do I have any interface segregation? Am I doing am I segregating my interfaces, or am I having all the methods in one interface? So basically now we are going to have different classes which is going to implement this contract, right? So what have we done is we have okay, so what have we done is we have created multiple classes, right, for each specific route, whatever we are taking. So that is nothing but what is called as my so that is nothing but what I mean by a strategy, right? For each route we have so for each route we have defined a specific strategy, right? So basically these are each classes. These classes are nothing but like strategy which I've taken out. So this is nothing but what is my strategy pattern, right? So it says you have different classes for each possible method, and then let it implement the common contract. This is nothing but we what is called as a strategy, right? So basically we have a single what do you say, a single contract, and then we are going to implement different different all these classes are going to yeah, basically we are going to have a dynamic, like at runtime we are going to decide what is going to run based on what we pass. Based on what we pass, so at that time the corresponding so the strategy or is something what is we are trying to, right? That strategy is we are saying what mode of payment we have. So what mode of what do you say? What mode of transport we select? Uh, that specific interface, that specific class implementing the interface will be called. Will be called at runtime, right? Will be called. So basically at run, I mean by what by runtime, what does it mean is you'll have a screen, right? And then you have, so in Google Maps, if you open, you have this, suppose like Google Maps, right? So you have in bottom or right, you have an option, right, to select which mode of transport. So which the mode of transport you select, based on that mode of transport you select, uh, corresponding distance is calculated, right? And this thing is going to happen at runtime because the application needs to be running, right? It's already in the CPU time. We are already giving it some CPU time, right? So basically we are already running the application here. So hence we say since we are already running it at runtime, so hence is what we say that the strategy pattern is going to work at the runtime. So because the selection option will become only at runtime, so that is what the strategy pattern is going to solve. Okay, so yeah, I guess that is all for this lecture. I'll see you guys in the next one with another pattern, and we'll try to understand like why or why the code is written that way. That is what our main goal is. So the code, I mean, why is the blueprint that made that way? So I'll see you. So the main advantage of using strategy pattern or main point is when you have different possible methods and you want to decide them at runtime which should run. We are designing this at runtime, right? For example, should I run my should I choose my mode of transport to be flight? Should I choose it to be walking? Should I choose it to be cycling? Right. So I'm deciding at runtime. So that is what is what do you mean by strategy? Basically, you have you select a specific class. This is something. And this class is basically my mode of transport, right? Is this, am I running? Am I walking? Am I cycling? So based on that specific class at runtime selection, will corresponding to that transport, the total distance and the time will be calculated. Okay. So yeah, I guess that is all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.